Hi, Wuhan, how are you? You missed the Oreo yesterday. Yes, you are the first one. Hello, hello. Hey, Andy. Okay, I will wait for about like 2 minutes, okay, and then I will start this. And if you guys want to try these questions, you guys can download the file. The file is in the description, okay? And today we are going to do the AP Calculus multiple choice questions, and this is the BC level, so it's just like Calculus 2, and it's about series, and we'll be looking at the convergence tests. Right, so we'll wait for like another 2 minutes or so. Hello, hello, hello. Thank you guys so much for coming, right? And once again, if you guys want to try these questions on your own, you guys can download the file. The link is in the description. You will stay and see Oreo. Okay, okay. Oreo is eating right now, actually. So, yeah, later. Yeah. Maybe I'll see if I can bring him here.
He's eating.
I'm sorry.
He's not gonna be very happy.
No. 啊！他抓我了。And oh man. Oh no. Okay. His. Okay. Okay. 不要，对不起，对不起，对不起，对不起，对不起，对不起，对不起。
Maybe later.
Maybe later.
Okay, you go back to eating now.
I'm so sorry. Sorry, I'm so sorry. Yeah. This is not enough space for you. I'm sorry.
Are you saying he's fat?
No, this is just like such a small place. I'm on the table, man. Yeah. Hmm. The 3 minutes mark. Okay. So we have another 30 seconds from here, right? So I'll give you guys the questions. You guys can take a look. But once again, if you guys would like, you guys can download the file. The file is in the description. Today we have 5 questions. These are from the AP Calculus BC level. Okay, so we'll be just see how to do the testing for the convergence of infinite series. And we will start because, as I said, this is the 3 minutes mark. Okay, and let's see if you guys. Uh, Okay, so let's see. For the first one, this is from 1969. Once again, it's about 50 years ago. And this is the BC level because for the series, it's always in the BC level only. All right, that's like a calculus 2 level. Okay, so the question is asking us for what values of x does the series 1 plus 2 to the x plus 3 to the x plus 4 to the x plus dot dot dot. And you guys have the nth term right here, n to the x power. And this is the infinite series. We want to see for what x value will make this converge. Okay? Well, this right here, it's actually just the p series. But let me put this down in the form that we know. We know better right here first. So for this is actually the same as saying, let me just write it out. Okay? We have infinitely many terms. We can put this down in the sigma notation. Let me use n going from 1 to infinity. And as you can see, 1, 2, 3, 4, 5, so on up to n, right? So you have the n as the base, and the power is just x. The first one is like 1 to the x, right? So it's the same as 1, of course. Okay, so this is a series, and as we know, and we better know this when you walk into the AP Calculus test, right? This is what we know. We know that by the p-test for the p-series, when you have the series in this form, when n goes from 1 to infinity, 1 over n to the p power, this right here converges if p is, anybody want to help me out? Let's see if I can get any participation. So comment down below right now. Yeah, she's happy. No, Oreo is a he. What do you mean? Let's see. Oreo is not eating Oreo, by the way. P is greater than 1, that's right. right here, this converges if p is greater than 1. This is the p test, okay? And right here, I will just show you guys all the work. And yes, the answer, somebody pointed out the answer already. So right here, I will just first put this down into that form. So I will have to write this down in the denominator. In another word, this is the sum when n goes from 1 to infinity. And we can look at this as 1 over n to the negative x power, okay? And now you see that this is pretty much our p right here. I just have to set negative x, and I want the p right here to be greater than 1. So I want to have negative x to be greater than 1. And then we can just divide it by -1 on both sides. So let me do that for you guys real quick. And we get x is less than, don't forget to switch the inequality symbol, and 1 divided by -1, of course, is just -1. And as you guys can see, the answer is just answer choice B. That's right, John. That's it. Okay, now I will give you guys about like 30 seconds to do the second one. Okay, and then if you guys finish, you can just like type the answer out, and then we will start too. Hi, Luis. Hi, Mark. Try this question, number two. Okay. John is just faking it. Okay. Okay. Please take my name. Ranjet, right? Blurry? Seriously? Let's see. How is this blurry? Let's take a look. How's this? How's the picture quality, you guys? It's kind of okay today. It's worse than yesterday, actually, for some reason. But anyway, try the second one. I haven't seen any correct answer yet. So I'm waiting for you guys, and then I will start. We can still see the answers. Okay. Oh, okay. We can still see problems. Okay. That's good. So we are trying to find out for what are all values of x for which the series, the sum goes from 1 to infinity, x minus 2 in the parentheses to the nth power over n times 3 to the nth power. We want to see where is this converge. Back, yeah. Frozen, no, I'm back. No, I'm back. Don't go. I'm back. Okay, I'm sorry. I don't know what happened. Okay, number two. Let's see if you guys can figure out number 2. Okay, I'll give you guys another 30 seconds or so. Because remember, if you are taking the AP calculus exam, you have about like 3 minutes per question, okay? And in fact, less than that. But yeah. You say E? Okay, so we have an answer, and let's see if we have the correct answer right here or not. Okay, so we are trying to find out all the value of x for that this series converge, right? And let me tell you guys, this is a quick way to do it. And I will do this in detail if there's any request, okay? First of all, I noticed that on the top, I have this raised to the nth power. On the bottom, we also have this 3 to the nth power, right? In this case, I want to make this part to be 3 as well. 3 and also -3. And you don't really have to worry to do the ratio test to really figure out the radius of convergence. You can actually just use the answer choices here. Because remember, this right here, you're just trying to test out which is the correct answer. You only have like 3 values to check. And let me tell you, we'll be focusing on -1 and 5, okay? Because you want to make this right here to be 3 to the n, and also -3 raised to the nth power, so that they will cancel out. So in fact, I just have to check either C, D, or E, all right? And I just have to check -1 and 5, and let's go ahead and do the work. So right here, I'm just going to check what if when x is equal to -1, right? Once again, I can actually get rid of answer A and B already, because once again, I want to make the top right here to be 3 to the n as well, so that that will be cancelled out on the bottom. And the only two numbers that will make the top to be 3 to the n is when x equal to -1, we get -3 to the nth power, and when x is equal to 5, because 5 minus 2 is 3, and then to the nth power, all right? Yes, Mohan, you got it. And then let's see, let's continue. Let's plug in -1. I'll show you guys all the work so that for the people who are watching, you guys can like take notes and study all this, especially the high school students who are taking the AP calculus test. All right, so let's plug in this right here. And for simplicity purpose, I'm just going to now write down the 1 to infinity, okay? So let's see, I have the sum when n goes from 1 to infinity, and we plug -1 to here. This is the x value, and I will show you guys all the work, okay? So -1 minus 2 and then raised to the nth power over n times 3 to the n. Okay, this right here is the sum when n goes from 1 to infinity. On the top, this is -3, because -1 minus 2, of course, is -3, raised to the nth power over n times 3 to the n, right? Okay, right here, this is, let's say, -1 times 3. So we can break this apart as the sum. We will first have -1 to the nth power times 3 to the nth power, and then over n, and then times 3 to the nth power. And of course, on the actual test, you don't have to show all the steps like this, but then, you know, I'm just making videos for you guys, that's why. And I like math too. Yes, Darshan, yes. Okay, right here, as you can see right now, we will just have the series when n goes from 1 to infinity. We have -1 raised to the nth power, and we can write it down as multiplied by 1 over n. This right here, in fact, converges. And can somebody give me a reason why that this is a convergent? And this is just for study purpose. I know this is convergent already, but why is this a convergent? And do we have a special name for that? Yes, this is a convergent, we can just say by alternating series test. Because ignore this part, just look at 1 over n. 1 over n goes to infinity. I mean, 1 over n goes to 0 when n goes to infinity. And 1 over n is always decreasing, so it checks, right? So we know when x is equal to -1, it works. And now we just have to check when x equals to 5, okay? And right here, I'll skip some steps. This is just going to be the series when x is 5 and then minus 2 to the n over n times 3 to the n. This is the series. This is the top, just 3 to the n over n times 3 to the n. This and that cancel. We have the sum 1 over n. So converge or diverge for this one? So Berger, what do you think about this? This is like converge or diverge? Diverges, okay? Diverges, and by what? Okay, you can use the p-test, or you can use the harmonic series diverge and things like that, whichever way you say, right? Because p is 1, so it's similar to what we talked about earlier, right? Harmonic series diverges, or you can also say the p series, because p right here is exactly 1, so I'll just put it down. By p is equal to 1, so it diverges, right? So this right here is actually no good, right? So when x is -1 is good, when x is 5 it's no good. And the answer is just answer choice E. We take -1, but we do not take 5, right? And once again, the radius of convergence for this one is just 3. Why? Because the easy way is because we have the bottom 3 to the n. And you also have to be careful that the power have to match, right? N power and nth power. Hi, Pat. How are you? Okay, so we will give you guys some time to try number 3. Number 3, number 3, number 3, number 3. For what integer k? And this right here, in my opinion, is not necessary because all these values, are greater than 1. but the original question stated k is greater than 1, okay? Anyway, we want this and that series to be both convergent. Ryan, the answer is D. How come? Cool. Okay, a lot of people got the right answer. Right, k is equal to 3. Okay, now, first of all, look at this series. We want this series to converge. So if you want this to converge, this right here, the k is right here. I hope you guys can see this clearly. All right, this is where the k is. It's in the exponent. If k is even, then on the top we will just get 1 over n, right? And that's going to give us this situation, which is a divergent. That's no good. So from here, we want to have, well, I should say we need to have k being odd, so that we can actually get the sum, and we will have -1 raised to the nth power over n. So we can actually get alternating series, right? Okay, and right here, as we can see, we have k over 4 inside of the parentheses and then raised to the nth power. This right here is a geometric series, right? Right, so based on k is equal to odd, we can get rid of a, c, and e, because now, among all the choices, we only have 3 and 5. We only want to have right now we are looking at this as a geometric series because the inside, right, by geometric series, this right here will converge if the inside is less than 1, right? The absolute value of that. So we really want to have the absolute value of the inside, which is k over 4, to be less than 1. And then among all the choices, in this case, k is the only number right here. When k is equal to 3, that will make this 3 over 4, right? So k has to be 3. So from here, we want to have k equal to 3 on this choice, right? Yes, hopefully you guys find this helpful. So the first page is about the p series and also the alternating series, and this is the interval convergent, and we also have one geometry series question right here. Okay. Okay, now moving on to question number 4. Okay. And once again, if you guys would like to try these questions first, you guys can download the file. The file is in the description. Okay. Now, for question number 4, this is from, oh my god, this is 30 years ago. Which of the following series converges? Okay, we have 3 choices, and I'm going to give you guys some time to think about it. Of course, you don't have to show all the work on the actual test, but you will need to be sure you are thinking this correctly, right? So I'll give you guys about 30 seconds, and I'll wait for you guys to just type out the answer. Oh, cool, JS. Cool. Yes. And I am waiting for the answer. So the answer is actually not B though, because one of the things is not converge. Well, we see Oreo at the end again. If you guys watch till the end, maybe. Oh wow, I have answers. This right here is not so much, huh? All right, so I have like a lot of you guys said A, and a lot of you guys said D. Some people say it's C, and okay. So let's see. Nobody likes number 2, huh? Right? So this right here, people say this diverge. Let's see, how shall I start this with you guys? Anyway, let's say for number 1, okay? Converge or diverge for this one? Is this a convergent or divergent? Convergent, yes. This right here converges. Why? AST, that's right, Matthew. Good. Alternating series test. Because you see, this is the alternating part, right? You have the -1 to the whatever power. And then this right here, this is 1 over 2 to the, sorry, this is 1 over 2n plus 1. This goes to 0 when n goes to infinity. It checks because the bottom goes to infinity right here. And this is always decreasing. You can also try it out. So we can use the alternating series test for number 1, and it converges, right? So 1 is correct. And now for number 2, converge or diverge. Okay, diverge. Very good. Why? It's not necessarily the P series though. The Nth term test, yes. You can also use the divergence test. Yes. First of all, let me just point this out. As you can see, this part, if you don't have the 1 over n, this is 3 over 2 to the nth power. This is like a geometry series. Because 3 over 2 is bigger than 1, so of course you know this diverges, right? However, you do have to account for the 1 over n right here. But it doesn't really matter because this is what I can do with you guys. Let's look at this on the top as, let's take the limit, okay? This is, a lot of people say this is the test for divergence, so I'll just put this down. This is the test for divergent. And let me show you. What we do by this is that we take the limit as n goes to infinity, and we just look at this part, okay? The nth term test, okay? You cannot do L'Hopital, by the way. Well, not, well, yes, kind of, you can do L'Hopital, but like, yeah, I'll leave that to you. Right here, I'm just going to do without L'Hopital. I'm going to put this down on the top. I will write this down as 3 over 2 raised to the n, and then over n, like this, okay? This right here, in fact, goes to infinity. Why? Because on the top, this is a much bigger series, sorry, a much bigger sequence when n goes to infinity compared to the bottom, right? So usually I would just say this is by my list. I will just write this down by the list. So what do I mean by the list? As n goes to infinity, all right? The smallest infinity that you can get among all the sequence that I usually would do is ln n, all right? And then this is less than or equal to, less than n to the p's power. And right here, we are saying that p is greater than 1. And this is less than r to the nth power. And right here, we are saying that r is greater than 1, right? So what we are saying is that so this is not p is greater than 1. P, oh man, I cannot erase anything. This is p is positive, okay? So you can actually have like 1/2. This still goes to infinity, all right? Yes, Wuhan, you got it right. And then, of course, the last one you can say this is like, if you want to finish it, this is n factorial next, and then the last one is n to the n, like that. But anyway, we're just comparing this to r to the nth power when r is greater than 1. This is way much bigger than n to the p's power, and this is p is equal to 1. So, you know, this right here goes to infinity. So this is like the quick way to do it, right? So this is the kind of like a quick way to do it, and especially when you're doing a multiple choice test, then you know this is actually all you need. So this right here diverges. That's all. Lastly, this right here. Okay, let's see. How many of you guys think this converges? Integral test. Good. So is it converge or diverge? Right, this right here actually diverges, and I will just write this down by integral test, okay? And if you are really planning to take the AP Calculus exam, you should have done this kind of questions like many times already. Some of these questions, you know, they just repeat, happen, and open over and over again and things like that. This is a rather famous one. You do the integral test and you check, you just check okay? The integral from 2 to infinity, and we change all the n to x, 1 over x times ln x dx, okay? And then from here, you can actually just integrate this by letting u equal to ln x, and I will let you continue. And you actually find out that this right here diverges, okay? And I will just tell you guys that the answer is just the first one, so therefore the answer is A, all right? Okay, if you guys got that right, excellent, right? And you guys get to see Oreo later on. Right, this is only from 25 years ago, right? 1993. I will have a video in the description for you guys to watch later on. In fact, I have done a similar integral right here in the past, so you guys can watch that. Right? So, which of this right here? This time we're looking for a divergent. Yeah, it's only 25 years ago. This is actually younger than me. This question is actually younger than me. I know it's sad. Okay, yes, a lot of you guys got this right. This right here, it's none, because everything here converges, right? So let's this time we'll do it backwards. This right here actually converges once again by alternating series test, or you can also say alternating harmonic series converges, right? This right here also converges because this is a geometry series, right? So I'll just put this down by geometry series where r is equal to 6 over 7, and you know r is actually less than 1, so we are good. How about the first one? How come this right here converges? How come this right here converges? I'll just put on by what? Technically, you cannot use the ratio test, because if you do the ratio test, you end up with 1, so that's actually inconclusive. Comparison test, that is correct, and depends on your teacher, I would say. Some teacher may have gone over the direct comparison test, or some people call that ordinary comparison test. So you do inequality check and things like that, all right? So that's actually okay. Or you can also do limit comparison test, right? So I will just write it down. Either version is okay. By comparison, and I will tell you we can check with the sum when you have 1 over k squared, like that. Of course, this right here, p is equal to 2. So this is a convergent, and then if you work out the comparison test, you also see that you can draw conclusion. So this also converges, right? So this right here is it, right? So hopefully you guys liked today's video, and as I said, as I promised the other students earlier, that I will do some BC level questions, and here we have it, right? This is number 1, number 2, number 3, and then number 4, and number 5, right? Hopefully you guys like this video, and of course I have to go find Oreo for you guys. Yes. Yeah, I will have to find Oreo. Right, let's see. Oreo, where are you? Can I show you? Hey, say hi to everybody, Oreo. Hey, Oreo, say hi to everybody. You're YouTube famous now, you know? More people want to see you than me, so yeah. Come on, say hi, don't be shy. Don't be shy. Say hi to Wuhan, please.
He's a little sleepy.
Oh, he is?
Yeah. I think he knows something's going on.
I'm sure too, yeah. Yeah, he is like, why are you filming me? Oreo.
It gets all weird when I have my phone up against him, so
Really?
I think he knows.
Aww. Yeah, Oreo is sleeping. Aww. Yeah, he is kind of sleepy right now.
Yeah, he's laying down.
Okay, hi you guys. Yeah, thank you guys so much for watching the video, alright? And as I promised, I showed you guys Oreo earlier, and then I'm showing you guys myself. So anyway, I will do more live stream for you guys later on, right? So just whenever I have time. I'm sorry, I am really bad in scheduling, but yeah. So bye. Thank you guys so much for watching. Alright, thank you guys so much for watching. Bye, bye, Wuhan. Bye, everybody. Bye. And I'll show you guys Luna next time if you guys watch my live stream. Okay, Luna right now is not available. So yeah, bye.